In this lesson, your old Uncle Frank is going to teach you how to do the calculations for chi-square using Excel. But before we do that, I want to make sure that you have a way of remembering how to say chi-square. This is a symbol. Chi is spelled C-H-I. Now I know some of you want to call it chi. Some like a chia pet or some other way, but chi is the way it should be pronounced. So I'm trying to think of a way of getting you to remember that. Remember when we were talking about correlations, we talked about rho. Rho looked like a fancy P, but it was actually the Greek letter R and spelled R-H-O and pronounced rho. Well, if we put these two symbols together, we'll get Cairo, and it's pronounced like the city in Egypt, Cairo. So it's also spelled C-H-I-R-H-O. And it turns out these two symbols together have some historical significance. It's actually a monogram called the Christogram, and it's a symbol of Christianity. So you'll see this chi with the letter rho in a number of different places having to do with Christianity. You'll see them on old Bibles, like here's from the book of Kells, which is about 600 AD. So this is medieval times. Now here you'll see a big chi, and underneath the right side of the chi you'll see this little rho, this P-looking thing. It's got a head at the end of it, which is pretty interesting. But you'll see this kind of on some Bibles, on the cover of some Bibles. This was a page in the book of Kells. Let's go a little less far away in history. Not much. Just to 700 AD. So again, this is medieval times. Here's a Cairo. This is in the Lindsfarne Gospel. And here you see a chi, and here the rho is a little bit more clear. Let's take another look at. Here's an amulet. An amulet's like something on a necklace, and people would wear this during medieval times to infer their Christianity. Also, here's one on a shield, and I'm sure that some of these were carried into the Crusades, which was much later, 1400 AD. So anyway, this Cairo, the only reason I'm emphasizing this is I really want you to know how to pronounce chi square. Now let's use our chi square now that we know how to pronounce it. Here's a question I saw in a recent research article that a student sent me. It said, is there a relationship between whether a patient is warmed before surgery and whether that patient develops wound infection? So we have a 2x2 table here. We have 2 rows and 2 columns of data. Whether or not the patient was warmed, there were 141 total patients that were warmed. 6 of those developed an infection. 135 of them did not. There were a total of 140 patients who were not warmed. 20 developed an infection, and 120 did not. We could look at this a different way. There were a total of 26 patients that had developed infections. 6 of those were warmed, but 20 of them were from the non-warm group. Or we could say that there were 255 people who were wound-free, or infection-free, wound infection-free. Of those 255 that were infection-free, 135 of them were from the warmed group, and 120 of them were from the non-warmed group. Do you see any relationship there? Does it look like warming a patient helps, or it doesn't help? I mean, maybe just by coincidence. Let's take a look and see how we would use our chi-square values. Well, there happens to be a program on this desk and also on the web called chi-square.xls. Now this is just a Excel worksheet that I developed. The first page of it looks pretty scary, and it says instructions on the first tab. If we look at the bottom, you'll see that it says instructions, example, 2 by 2, 2 by 3, 2 by 4. This is the size of the table. Well, we have a 2 by 2 table. There was yes, no for each category. So that's a 2 by 2 table. So we'll click on the 2 by 2 tab to go to that page. Now when we click on the 2 by 2 tab, we get a page that looks like this. And what I want to do is we'll zoom in on that top part. So let's zoom in on the top part. There, that'll make it a little easier to see. And we enter our data in the yellow areas above the, you see the orange cells that say A, B, C, D with white letters? We're going to put our data in the yellow cells above those. So in C4, we'll put our yes data. In D4, we'll put our yes, infected, but no, not warmed data. So we'll enter our data in those 4 cells. Now once we do that, and we put in our 120, our last number, and we must press enter so that we really entered it in that cell, then not only will we have these 4 numbers, but they'll total up for the columns and the rows. Not only will we get totals, but we'll get percentages. We'll see that a little over 50% of the patients were warmed, and a little less than 50% of the patients were not warmed. We'll see that of all the patients, 9.25% of them developed an infection, and 90.75% did not develop an infection. Also, when we entered in our 6 or 20 or 135 and our 120 in those yellow cells, they were also automatically entered into the observed cells down below. Here we have A, B, C, D, and we have the observed cells 6, 20, 135, and 120. Now next to that is the expected number of cases we would expect in each cell if there's no relationship between wound infection and whether or not the patient is heated. So we would expect in cell A, which is the yes category, while we saw 6 patients who were warm develop infection, if there was no relationship between infection and warmth, body warmth, we would have expected 13. In cell B, we saw 20 people in the non-warm group develop infection. If there was no relationship between body warmth and infection, we would have expected to have only seen about 13. So maybe there's something going on here. Let me focus in on these observed expected values a little more. Let me zoom in on that. And we'll see that to the right of that, there are the chi-square values. And at the bottom, in the blackened cell, we have a chi-square value of 8.4174, rounds to 74. That's our chi-square value. That's our observed chi-square. We can also see down here, we see what our degrees of freedom are. Our degrees of freedom are 1. There's a red arrow pointing to that. There's also our critical value at an alpha of 0.05 is 3.841. If we wanted a 0.01 value, we would have used 6.635. And we see our p-value. Now remember, our p-value tells us what the probability of our being wrong if we reject the HO. And in this case, it says our probability of being wrong is just 0.0037, which is pretty low. Now we can tell this data is significant. We can tell that because our observed value, 8.417, is higher than our critical value of 3.841. So we know we're going to reject HO and say our data is significant. Another way of knowing is to look at our p-value. Here our p-value is 0.0037. Well, that's less than 0.05. So we're willing to make the bet and reject the HO. So that would be significant at a 0.05. It's even less than a 0.01. So had we used an alpha level of 0.01, this also would have been significant. Let's do our steps, our 7 hypothesis testing steps. I always start with step 2 because I'm your weird Uncle Frank. So step number 2 is that alternative hypothesis. What it is that we're trying to show. And we're trying to show that the 2 categorical variables are dependent, or they're related to each other. That is, the presence or absence of infection depends on whether a person was warmed or not before surgery. Now let's fill in the opposite of that, which is our null hypothesis, which is step 1. Step 1 would be the HO is the 2 categorical variables, warmth status and wound infection, are independent. Whether or not an infection develops is unrelated to whether that person was warmed prior to surgery. Now, these are pretty wordy. Remember when we did HOs before, we just had the mu of A equals the mu of B. Or we'd have rho equals 0. Pretty simple. These are pretty wordy, but that's one of the disadvantages of the chi-square. Other than that, it's pretty easy. Let's go to step 3. Step 3 is, like always, we just set our alpha, and we set it at 0.05, which is what we normally do. Then we have a rejection rule. We're saying rejection rule, reject HO if chi-square comp is greater than or equal to. Now this is a little different. Before we used to put absolute values around our comp number. But with a chi-square, that doesn't need to go there because in chi-squares, we're squaring everything. If it would have been negative, a negative squared is a positive. If it would have been positive, a positive squared is positive. So all chi-squares are positive. We don't have a negative chi-square. So we don't need the absolute value sign. Let's go back to our spreadsheet and see what our chi-square our critical value would have to be. And here our critical value is 3.841. So this is what we put here in step number 4. So we put rejection rule, reject HO if chi-square comp is greater than or equal to 3.841. Step 5, we just put computation of test statistic colon chi-square comp equals, and we can also find what that equals on our spreadsheet. That's in the darkened cell, the black cell. So 8.4174 is what that rounds to. So we'll take that number and put it here, 8.4174. Now we have to look at our computed value of 8.41 and compare that to our rejection rule. It says reject HO if our chi-square comp, which we now know is 8.4174, is greater than 3.841. Well, 8 is greater than 3. So definitely our chi-square comp is greater than our critical value. So we do get to reject HO if it's greater, and it is. So step number 6, we just say decision, reject the null hypothesis. This leads us to our conclusion, our 3-part conclusion. And whether or not we reject it, step 7 always starts the same way. It says conclusion at an alpha level of 0.05, comma. Now comes our statement, and here it was significant. So we'll say at an alpha level of 0.05, warming patients prior to surgery significantly decreases the likelihood of wound infection. That's pretty interesting. So now we just add our statistical string. Now the first thing we tell in our statistical string is what kind of statistic we did. And we did a chi-square. That's followed by a parenthesis. Now in the past it's been followed by a parenthesis that has degrees of freedom. And chi-square does the same, has degrees of freedom, but it adds something. It also adds what the number of patients were in the entire study. So let's come back and look at this. We had degrees of freedom were 1, See the red arrow pointing to DF equals 1. And then above that we have another red arrow, and it's pointing to 281. That's the total number of subjects that we're in the study. So here we have chi-square, parenthesis 1, which is our degrees of freedom, comma, n equals 281. Now we have to say what our chi-square value equals, and we can get that from step number 5. We see that our chi-square equals 8.41. So we'll put that equals 8.4174, comma. Now the next thing that comes is our p-value. We have to go back to our spreadsheet, and there's our p-value. Our p, I have a red arrow pointing to it, equals 0.0037. Now, the reason there's a zero, a leading zero before the decimal, is because stat programs usually don't follow APA format. But as nurses, we need to. So here, we'll leave the zero off that's before the decimal. And we'll just write P equals 0.0037. And that is the last of step 7. Now let's look at all 7 steps together. What we see is our HO and our H1, our null hypothesis and our alternative hypothesis are both pretty wordy. That's kind of a characteristic of chi-square. Step 3 is the way it always has been. We just say what our alpha equals. Our rejection rule is pretty much what it's been before, but we don't need the absolute value sign. So we say reject HO if chi-square comp is greater than or equal to. Step number 5, we just put what our test statistic was, same as always. 6, same as always, we just say reject HO, or we say fail to reject. In this case, we rejected HO. Step 7, we have our 3-step conclusion. Again, the first step is just to say what the alpha is. Second step is to say what our conclusion is in words. And our third step is to have the statistical string. The statistical string differs in 2 ways here. One way is that besides just having the degrees of freedom in parentheses, we now have to add what our number of subjects were. The other is here I didn't say whether it's 1-tailed or 2-tailed. Most people don't when it's a chi-square. But there is if you get really tight into statistics, there is a 1-tailed versus 2-tailed kind of chi-square. So you might see that, but I'm not adding it here. And that does it for the chi-square. I hope you remember how to say chi. Remember, it's chi as in chi-rho. Thank you.